Okay, today we are solving February March 2024 paper 22. Okay, and we start with question number one. Read question very carefully. It says table 1.1 lists some SI quantities. Complete the table by indicating with a tick which row is an SI base quantity. Now, listen very carefully. It has to be a base quantity, not a base unit. Now, which one is a base quantity? Current is a base quantity. Mass is a base quantity. Actually, you should remember all list of all the basic quantities. For example, base quantities. There are seven base quantities. Number one, mass. Two, length. Three, time. Four, current. Five, temperature. Six, intensity of light. Seven, amount of substance or matter. Listen very carefully. One mark is there for ticking these two, and it also like mandatory that the these two blocks are empty. Okay, so if you put a single tick anywhere else, you lose mark. Use the definition of power to determine the SI base unit. Power is work done divided by time. Work done is force multiplied by distance divided by time. Force is mass into acceleration into distance divided by time. So what is the unit for mass? Kilogram. Unit for acceleration? Meter per second square. For distance? Meter. For time? Second. Put these units over here and then simplify. Kg. Meter per second square. Meter divided by second. Now kg m2 s minus 2 minus 1 minus 3. So SI base unit is going to be kg meter square s minus 3. If this is SI base unit, what is power's SI unit? Now, a light meter is used to measure the intensity of light in a classroom. Daylight is incident normally on the sensor of the meter. Now the sensor has an area of 2.2 centimeter square. The reading on the meter is 950 watt per meter square. Calculate the power of daylight incident on the sensor. Now, it is just simply mathematical question. It is a math question more than a physics question. We're saying 950 watt for 1 meter square. So if we have 2.2 centimeter square, how many watts will be there? Now, how many centimeter squares are there in a meter square? 1 meter square is 1 meter is 100 centimeter. 1 meter square is 100 by 100, that is 10,000 centimeter square. So the question is saying I'm replacing 1 meter square with 10,000 centimeter square. Okay. Now, if we have 10,000 centimeter squares, 950, 2.2 centimeter square x, we can solve this by cross multiplication. So the question mark will be 2.2 into 950 divided by 1000. So let's use calculator. 0.22 into 0.95. 0.209 watt. You can make it 0.21 watt if you want to answer in two significant figures. And if you are good with three significant figures, then it has to be 0.209. Okay, that's it. That is question number one. Moving on to question number two. Define acceleration. Whenever we have to define a quantity, the simplest way to define a quantity is by writing down the very basic formula. So you can do acceleration as change in velocity divided by time. Or you can write a statement. Acceleration is rate of change of velocity. But my recommendation at do only one of these two. Do not try to do both of them. Olympic driver stands on the platform above a pool of the water. When the driver is on the platform, his center of gravity is a vertical height of 9 meter above the surface of the water. The diver jumps from the platform with a velocity of 5.9 meter per second at an angle of 60 degrees to the horizontal. The air resistance is negligible. When the diver hits the surface of water, his center of gravity is at a height of 1.2 meter. Calculate speed of the diver at the instant he hits the surface of water. Hmm. No, loss of gravitational potential energy. Listen, overall, this person is here. This is where the center of gravity of the person is, and this person is now here. So overall, this person has gone down. Okay? Object has come down by how much? If on the top it is at 9 meter from the surface, at the bottom it is 1.2 meter from the surface. So I think it is 7.8 meters. How much object has net fallen down? Now, object might have gone up and then fell down like this. Okay, but overall, object has gone down by 7.8 meters. So object, or in this case, the diver has lost gravitational potential energy. This gravitational potential energy, loss of gravitational potential energy, should be equal to gain of kinetic energy. Should be equal to gain of kinetic energy. So loss of gravitational potential energy is mg delta h equals to gain of kinetic energy 1 over 2 m v square minus u square. Remember, it is not about the final kinetic energy. It is about change of kinetic energy. We can clearly see the mass becomes irrelevant. So 2gh plus u square square root. So it is going to be 2 into 9.8 into 7.8 plus 5.9 square. 2 into 9.8 into 7.8 plus what was the value? 5.9 square. So you get 187.68. So finding square root 13.7. I think it is straightforward. 13.7 meter per second. And if you want to answer in two even figures, you can round it off to 14 meter per second. The diver
Sir,
enters the water. Yes,
sir, in this question, your velocity थी, why didn't we break it into its components?
we don't need to. We like it doesn't matter whether it is the vertical velocity or the horizontal velocity. Object has certain amount of kinetic energy, and when it falls down, it gains further kinetic energy. And using the final value of the kinetic energy, we can find out final speed. And see, we are finding speed. We're not concerned with the direction of the motion in this case.
Okay, okay.
The diver enters the water and decelerates. What can be the reason for that? Because water is more dense as compared to the air, so there will be a bigger drag force over there. Plus, there will be a bigger upthrust. Describe and explain variation of the viscous drag force acting on the diver in the water as he moves downwards. So, what will be happening to the diver? Now, see that this question is a bit tricky. Normally, what question we do is object falls down, object is gaining speed, so drag force increases. But in this case, object has entered the water with the maximum speed. It will enter into water, it will experience force. Not only the acceleration of the object, but the speed of the object is also going to decrease. Okay, so viscous drag of the force acting on the diver in the water as he moves downwards in the water. Okay, diver enters water with maximum speed. This causes a drag force, which is more than weight. So diver slows down and drag force decreases on him. Okay, so when diver goes into the water, speed decreases, and this causes the viscous drag force to decrease. It is different from the normal question. The normally question is that object is falling down, speed is increasing, drag force increases. Okay, the diver has a volume of this, the density of the water is this. Show that the upthrust acting on the diver uh, when he is entirely underwater is 740 Newton. Listen, uh, upthrust. What is the formula for upthrust? Weight of fluid displaced. Upthrust is equal to weight of the fluid displaced. How can we find weight? How can we find mass? Mass will be volume of the fluid displaced multiplied by density of the fluid. Density multiplied by volume is mass, and by multiplying with gravitational field strength, this will become upthrust. Now,
सर अपथ्रस का फॉर्मूला रो जी एच नहीं होता?
नहीं वो प्रेशर का होता है VGH होता है वॉल्यूम इंटू density into gravitational field strength. So it is 7.5 into 10 to the power minus 2 into density is 10 to the power 3 into 9.8. So what is 9.8 into 7.5? 73.5 into 10 to the power 2. So it is 735, which is approximately equal to 740 Newton, hence shown. At a particular instant, when the diver is entirely underwater, his horizontal velocity is zero. The viscous drag force acting on him at this instant is 950 Newton, vertically upward. The diver has a mass this kg. Determine the magnitude and direction of acceleration of the diver. So this is the diver. What forces are acting in what direction? There is a downward force of weight, which is 78 G newtons. Upthrust is 740 newtons. And the viscous drag is 950 Newton upward. Now, determine the magnitude and direction of the acceleration of the diver. Now, acceleration equals to net force. Net force is going to be 950 plus 740 minus 78 into 9.8 divided by 78. I hope you remember that acceleration equals to force divided by mass. If you know the net force acting on the object, dividing that force with mass, you can get acceleration. So we're going to be, hmm, let's use a calculator to find out. 950 plus 780, I guess. To 780, 740. Mm, 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 mm. I think it is 740 equals minus 78 times 9.8. So we have 925.6. 925.6 divided by 78. Do not round off intermediate calculations. Okay. Do not round it off to 930 or something. Divided by 78. So we have 11.866. And this is where you round off. 11.7 meter per second square. Or you can also write it 12. If you want to answer in two cent figures, it is 12. If you want to answer in three cent figures, it is 11.7. Direction is going to be upwards. Okay. Now moving on, a thin metal wire X diameter 1.2 into 10 to the minus 3 is used to suspend a model planet. Hmm. The variation with strain and stress is given. The strain in X is this. Use the figure to calculate the force exerted on the wire by the model planet. Hmm. Don't forget the diameter. We need that. Formula for stress is force over area. And for this particular case, because area, it is not directly area given, so we have another formula that says stress equals to 4F over pi d square. But the thing is, we have the value of strain, not of stress. If you go back, you will find that we have a graph given, which is between stress and strain. So how much strain is given? 5.4 into 10 to the minus 3. 5.4. This is 5. This is 5.4. 5.4 the graph, and then we see the corresponding value on the other side, which is now 1, 2, 3, 4, 5. This is 0.7. This is 0.72. Don't forget this unit, because this unit has this G in it. G means 10 to the power 9. So any number you pick from this axis will come with a built-in 10 to the power 9 thing. Okay. So if you think it is 0.72, it is 0.72 multiplied by 10 to the power 9. So 10 to the power 9 is in everything that is on y-axis, and 10 to the power minus 3 is in everything on the x-axis. So that is why I only went for 5.4. Okay, because 10 to the power minus 3 was already there. Now, if we need d, no, so we need force. So F equals to stress into pi into d square divided by 4. So stress was 0.72 into 10 to the power 9 multiplied by pi multiplied by d. I guess it was 1.2 something. What was 1.2 into 10 to the power minus 3? Yes, 10 to the power minus 3. 1.2 into 10 to the power minus 3 whole square divided by 4. Point 72 into pi into 0.01 0.0012 multiplied by 0.0012 divided by 4. So it is 8.14 into 10 to the power minus 3.
So the answer is 810 almost.
814.
अच्छा सही सही सही.
Hmm. Good guess though. 810 newtons. The elastic potential energy is 0.31 joule. Calculate the original length of the wire before the model planet was uh, attached. Listen, if we know elastic potential energy, do we know the formula for elastic potential energy? Elastic potential energy is
1 by 2 fx.
1 by 2 Fx. If elastic potential energy is given and tension is given, those force is given, can we find extension? Force was given 810 Newton. Using this 810 Newton, can we find out extension? Extension equals to 2 times elastic potential energy divided by force. Point 62 divided by 810. 0.000765 meter. Now we know the strain was also given at the same value. What was the strain? Strain was uh, it is 5.4, I guess. Yes, 5.4 into 10 to the power minus 3. Here we go. We know extension over unstretched length equals to strain. So length is going to be extension divided by strain. So extension is 7.65 into 10 to the power minus 4 divided by 5.4 into 10 to the power minus 3. Zero point 0.1417. See, this is why the question was for 3 marks. There was a link part. In the first part, you had to find out the extension using the energy, and then you have to use strain and uh, extension to find length. That's why this question is for 3 marks. Wire X is replaced by a new wire Y with the same original length and diameter. Okay, so he's just putting these two things, is making these two things irrelevant, but double the young model. Wire Y also obeys Hooke's law. On figure, draw the line representing the variation with strain and stress for Y. It has double this. So, simply, do you know that gradient of this graph, Young's modulus is gradient. So, if we have a double gradient, sorry, double Young's modulus, we should have double gradient. And he just confused you with same length and same diameter. If he tells you the diameter, if he changes the diameter, if he does not change the diameter, the stress and strain graph for any wire, if it is made of the same material, should have same Young's modulus. Its Young modulus will not change because of its physical features, other than uh, ratio between stress and strain.
Sir, if you only half the diameter of the wire, your model should still stay same.
Yes,
And even the graph will be as well.
yes.
Sorry, ठीक है. Okay.
Okay.
Okay,
So
sir.
when very easy way of doubling gradient is, you can pick any point. For example, I'm picking this one. I hope you can see. Let me use a highlighter. I'm using this point here because this is at a fixed point of 6. Go to the half of that value, which is 3 here. Come here, make a mark here. Yes. Now join this line with the origin. Mhm. Now you can always extend the line to the foreign limit. So this would be the line for wire Y. Okay, if it has double Young modulus, it should have double gradient. Okay, now moving on. This question is done. And if the last part, only the last part is given without the whole question, the last part is completely independent of the whole question. If I tell you there is a stress and strain graph without even values, okay, here we have stress and strain. This is wire one. If he tells you the wire two has double Young modulus, it should be a line like this. Half the Young modulus, line should be like this. So you don't need any calculation or any other value, any other thing. A nucleus P undergoes a alpha decay to form nucleus Q. Complete the alpha particle. Alpha particle is a 4 2 particle with a nucleon number of 4 and a charge number of 2. So the Q will have values 211 and 82. State the principle of conservation of momentum for an isolated system. Total momentum is always conserved, or you can say total momentum before collision is equal to total momentum after collision. This is a law. Yeah, this is something that you need to remember. This is a knowledge-based part of the examination where a student is required to remember things. Before the decay, the nucleus P has a speed 3.2 meter per second. After the decay, the nucleus Q is stationary. Calculate speed of alpha particle after the decay. Hmm. So if all the momentum of this thing is converted over there, uh, this is something with a mass of 215 moving this way with a velocity of 3.2 into 10 to the power 5 meter per second. Now after collision, this is at rest. 211, and if 4 mass of 4 is going this way, okay, and we need to know the velocity of this thing. Now how can we find the velocity? The total momentum is always conserved. So total momentum before collision equals to total momentum after collision. So 215 into 3.2 into 10 to the power 5 equals to 4 into V. Okay, because the momentum of this has to be equal to momentum of this. Total momentum before has to be equal to total momentum after, because 214 has a momentum of 0. So V is going to be 215 into 3.2 into 10 to the power 5 divided by 44140.8, 8 into 540, 0, 5, 8, 12, 1, 17 into 10 to the power 5. I'm getting 1.72 into 10 to the power 7 meter per second. I think you can confirm that if you have calculator. If you want to present your final answer in two significant figures, it has to be 1.7 into 10 to the power 7 meters per second. So it was a small question.
Sir,
It
one
was more.
question.
It was more of a momentum question than of a radioactivity question. Yes.
Yeah, the unified atomic mass unit and rest mass of proton, they
Mhm.
both almost have same mass, no? So is
Yes.
any difference between them? Like, is any difference that what is this one U, which is like sort of a value of unified atomic?
Like in AS level, I will tell you that there is no difference. It is same. But in next year, I will be correcting myself and will be explaining the differences over there. But for now, you have to consider them same.
Okay. And electron also have a mass that is hidden in the data sheet.
Yes,
So
yes,
if
it
you
is.
can,
It is 2,000 times lighter than approximately 2,000, 1,800 something time lighter than proton or neutron or U. So that's
so you will take
why
an
it is
interval.
considered zero.
Actually,
It
okay,
has
okay,
mass.
sir.
Every particle has. If we call it a mass, even in later classes you will understand that the photons, which are purely energy particles, they have relative mass. But after the direction of propagation of energy, state what is meant by transverse waves. Particles of medium oscillate perpendicular to the direction of propagation of energy. Okay. A space telescope is designed to detect electromagnetic radiation with wavelength in range of 12 micrometer to 28 micrometer. Okay. So state the region of electromagnetic spectrum for this region. Now, this is larger. These wavelengths are larger than visible light for sure, because 1.2 micrometer is 1.2, 12 micrometer is 1.2 into 10 to the power 5 meter, and 2.8 into 10 to the power 5 meter minus 5. Sorry. Okay. So visible light has a value from 4 to 7 into 10 to the power minus 7 meter. So obviously these wavelengths are larger than visible light. Okay? So it has to be on the left side of the electromagnetic spectrum than visible light, and these wavelengths are smaller than microwaves, because microwaves are in centimeters. Okay? So I will go with infrared. The detect A detector on another space telescope detects electromagnetic wave. The signal from the detector is transmitted to Earth and displayed on oscilloscope. Signal. The time-based setting on the oscilloscope is these many seconds for each centimeter. Calculate the wavelength of the detector. Oh, good. It's giving us some information about the time period and asking for uh, wavelength. And see, this is why there are 3 marks, because there will be double calculation for this one. First, you have to find out the time period. If I need to start with a relative point. I'm starting from this point here. Where do you think one complete wave is made? Here. Now, how many boxes are there? This, which appears to be wavelength, is actually not a wavelength, but time period. Okay. So how many boxes are there? 1, 2, 3, 4, 5, 6. So time period is going to be 6 times 5.0 into 10 to the power minus 15, which is 30. So 3.0 into 10 to the power minus 14 seconds. This is going to be a time period. This is the time period. Now, how can I use this time period to find frequency, and then I can use the frequency to find wavelength? But if I'm smart, I should remember a formula for what is the formula for speed? Speed of wave is f lambda, but f equals to 1 over t. So I can make another formula, v equals to lambda divided by t. So that gives me an idea. I can directly find lambda by multiplying time period with speed. So lambda is going to be 9.0 into 10 to the power minus 6. It is still in infrared path. Coherent visible light of single frequency, is incident normally on the double slit. This produces a pattern of bright and dark interference fringes on the screen as illustrated in figure 6.1. There are seven bright fringes. Explain how the pattern of the bright and dark fringes is formed. Now, you need to understand that when light passes through these slits, it will diffract. The light, when passes through slits, it diffracts, which means spreads. This gives rise to interference, where waves from two slits meet in phase. They produce constructive interference, and where they meet with a phase difference of 180 degree. They produce destructive interference, where there is constructive interference. We observe bright, what did he say? Fringe, yes, bright fringe. If you want to write a line, you can also say that where where there is a destructive interference, we observe a dark fringe. The distance between the center of the fringes X and bright fringes Y is in the pattern is 10.2 millimeter. The slit spacing is 1.2 millimeter. The distance from the slit to the screen is 3.1 meter. Calculate wavelength. Okay, it is a very simple question. He's giving you 3 marks because of too many conversions that we have to do. Distance between center of bright fringe X and bright fringe Y. First, we have to go to the diagram and bright fringe X and bright fringe Y. How many spacings are there? One, two, three, four, five. So, how many fringes are there? Fringe separate. Fringes are seven. How many fringe separations are there? How many fringe separations are there?
You will divide 10.2 with the 6, no?
Yes, it is like spacings. Don't count the fringes. We only count the spacing. One, two, three, four, five, six. So fringe separation is 10.2 divided by 6, that becomes 1.7 millimeter. Now, the formula is lambda t equals to ax. We need lambda, so it will be ax over d. A is slit spacing, which is 1.2 into 10 to the power minus 3 multiplied by x, which is 1.7 into 10 to the power minus 3 divided by d, which is 3.1. 1.2 multiplied by 1.7 divided by 3.1, 0.658. 0.658 into 10 to the power minus 6. So it is 6.6 into 10 to the power minus 7 meters. So it is visible light, okay? Because it is between 400 to 700 nanometers. So it is visible light, most probably very close to orange, I guess. The light is replaced by the different visible light with a shorter wavelength. State how the new fringes separation will compare to the original fringe separation. Fringes will appear closer. Okay. Smaller fringe separation. A stationary wave is formed on a stretched string. This PQR are point on the string. On figure 6.2, draw X to show the position of a node. Node. Nodes are the point which always stay on the uh, mean position. Okay. So we have 1, 2, 3, 4. We can put X anywhere. Yeah. So I put X here. Zero. State the phase difference between P and Q. Any two point particles between two consecutive nodes, they are always in phase. So the phase difference is going to be 0. State the phase difference between P and R. Any two particles on either side of a node, they are 180-degree out of phase with one another. If we have a loop like this, so all these particles are vibrating in phase, all of them. Yeah. Yeah. So they're all in phase from one node to another node. But if we have a node in the middle like this, like if these points are coming down, then these all points are going up. Yeah. So if these points are coming down, these points are going up. So any one point here and any one point there, regardless how far or close it is, if it is in two consecutive loops on either side of a node, the phase difference is always going to be 180-degree, and no matter how far or close they are between nodes, they are always in phase. Their phase difference is going to be 0. Define electric potential difference. Difference of electrical energy per unit charge between any two points is called electric potential difference. Now, a cell of electromotive force EMF 1.8 volt and internal resistance R is connected in parallel with a resistor of resistance 6.0 ohm and filament lamp as shown. Switch S is open, ammeter reading is 2.5. Determine the internal resistance R of the cell. Now, how can we find out internal resistance? S is open, ammeter reading is 0.25. So this tells me that the potential difference for the 6 ohm resistor is, if there's a current of 0.25 ampere, what is the potential difference for this one? V equals to IR, 6 into 0.25, so it is 1.5 volt. If this one is getting 1.5 volt, cell here is providing 1.8 volt, and this here is getting 1.5 volt. How many volts are consumed by this one here?
It's 0.3 volts.
Good. 0.30 volts. Now, if we know the voltage is 0. Sorry, voltage is 0.30, yes, 0.30 volt. Current is 0.25. Can we find internal resistance? Because V equals to IR. So R equals to 0.30 divided by 0.25. I guess it should be 1.2 ohm. 1.2 ohm is the internal resistance. Time this is closed. Shows the variation with time t for the ammeter reading. State whether the EMF of the cell after T1 is greater, less, or same. EMF does not depend on anything which is happening in the external circuit. Okay, so it is going to be same. EMF does
लेकिन
not depend
resistor
on what is going on in the external circuit. Terminal potential can change, but EMF stays the same. By considering the effect of the lamp on the total resistance of the circuit, explain variation in the ammeter reading, variation of the ammeter reading shown in figure this. So there is a constant current before that. When we turn on the lamp, the resistance of the circuit decreases a lot. Lamp turns on. When lamp is turned on, the temperature of the lamp will be increasing. This will cause the resistance of the lamp to increase. When the resistance of lamp will increase, the total current will decrease because the current through the lamp is decreasing. So when lamp is turned on, total resistance of circuit decreases. So more current, more current through ammeter, temperature of lamp rises, which increases the resistance of lamp So current through lamp and ammeter decreases.
तो एक सवाल है
Yes.
sir, the charges now, the charge carriers, as a
Hmm.
complete one loop now, the final energy now is zero. So it will have to go to the cell to get the energy for me. So won't the EMF decrease because the
I could not understand your question. Can you repeat your question? Sorry.
yeah I'm saying that the charge carriers are moving around the circuit. After it passes to all the components, na, its energy is zero. So it
Hmm.
has to take the energy from the it has to take the energy from the cell. So won't the EMF of cell decrease because of that?
No, it is not the EMF. EMF will not decrease, but the ability of keeping that EMF same will.
Okay, sir.
Okay, because that EMF is a consequence of the energy that is stored in the cell in the form of chemical energy or some other form of energy, which has been converted into electrical energy. When cell provides that electrical energy, EMF stays the same, but ability to keep that EMF same, because remember the cell is converting some other form of energy into this one, that form of energy is decreasing. Okay, and when cell will run out of that form of energy, the potential difference of the cell or EMF will decrease and sometime it will become zero.
Okay, sir. Okay.
State the name of the class, group, or fundamental particle that contains a neutrino. Or neutrino belongs to leptons. Okay, neutrino belongs to leptons. A hadron P has a charge 1e, where E is an elementary charge. The hadron P is composed of a down antiquark and only one other quark. Identify a possible flavor of this quark. Good. Now, what is anti-up? Up quark has a charge of 2 by 3 and down has a charge of minus 1 by 3. What will be anti-up? Minus 2 by 3. What will be anti-down? Plus 1 by 3. So we already have 1 by 3. How much charge we need to complete 1? 2 by 3. So we can use up quark. What quarks have positive 2 by 3 charge?
The
Let me
up
write
quark
it over
now.
here. Up
It can also be a top quark or a chop quark.
charge or top. They all have 2 by 3, 2 by 3, 2 by 3. And down, strange, bottom, they have minus 1 by 3, minus 1 by 3, minus 1 by 3. Okay. So we can use up or char or top. State what type of hadron is P. The one that contains a quark and antiquark, it is a meson. A meson contains a quark and an antiquark. Nucleus Q undergoes a radioactive decay to form nucleus R, emitting an anti-neutrino and another particle X. State what particle X represents. When we are getting an anti-neutrino, so this must be an electron. Okay. or beta minus. Compare the nucleon number of Q to R. Same. Whenever a beta particle is released, because a proton is converting into neutron or neutron is converting into proton, there will be no difference in nucleon number. Compare the charge of Q to R. R has +1 more than Q because it has uh, one more proton. Okay, because a neutron has been converted to proton, so it has one more proton. So R has one more charge than Q, one more positive charge than Q. I think this is it. Yeah. Thank you very much. See you next time.